Hello friends. First of all, welcome to my channel, and I hope everyone is doing great. So today we are going to learn about basic concepts of geometry. So we will be starting with triangle, then we'll move to circles, and then quadrilaterals. So today we are going to talk about basic concepts of triangle, then types of triangle, and some of the formulas which we'll use for solving numericals, and some of the basic properties of triangles. So first we'll start with basic concepts. So first maybe I'll start with definition of triangle. What is triangle? So triangle is a two-dimensional shape which has three vertices, three sides, and three angles. So in this case, if I draw a triangle, it should be like this. So this is a triangle ABC. So it has three sides, three vertices, and three angles. So here angle A, angle B, and angle C. So very basic property of triangle is sum of the three angles of a triangle is always 180 degrees. So if I take this example of triangle ABC, so here angle A plus angle B plus angle C should be 180 degrees. So we'll move to the next term, which is called altitude. So if I draw one line, we'll consider the same case of this triangle ABC. So suppose if I draw a line from A, which is perpendicular to this side BC, which I'll call this line AD. So the line which is perpendicular to a side and passing through the opposite vertex is called altitude. So in this case, the altitude of side BC is line AD. So I'll just name this as altitude. We'll move to another concept which is called median. I'll consider another triangle here. Triangle DEF. So suppose there is a point on side EF which divides the side EF into equal parts. So I just name that point as G. So it's a midpoint of side EF. So if I draw a line starting from D to G, which the point G divides side EF into equal parts. So this line DG I'll call as a median. Median has very interesting property. So median always divides a triangle into equal parts. So suppose if I consider this part DEG, it has area A1, and there is another part DGF, it has area A2. So in this case, median always divides the triangle into two equal parts. So A1 here, which is area of part DEG, and A2 here, which is area of part DGF, should be equal. There is one more property of median. So suppose if I draw a median of all three sides. So DG is median of side EF. If I draw another median of side DF, I name it as EH. And if I draw another median of side DE, which is, I'll just name it as FI. So the point at which three medians intersects, it is point C. I call this as centroid. And centroid divides this medians in ratio 2:1. So if I consider DG, it's one of the medians. So in this case, DC by CG should be equal to 2:1. And same applies to other medians. So if I take an example of other median, so here if I have CF upon CI should be equal to 2:1. And the third median EC upon CH is equal to 2:1. So these are basic concepts and properties. We talked about the sum of three angles, which is 180 degrees. Then we talked about altitude, and then medians and centroid, and the different properties of median. Now we'll move to different types of triangles. So let's start with different types of triangle. So we have made three types of triangles based on its angles and different properties. So equilateral triangle, it has a property that all three sides of a triangle, if they're same, then we call that as equilateral triangle. If I consider the same triangle name ABC, if all the sides and all the angles are same, then we call it as equilateral triangle. So equilateral triangle, the angle is always 60 degrees and all three sides are equal. In isosceles triangle, two of the sides of triangle, if they're same, we call that triangle as isosceles triangle. So in this case, side DE and DF, I'm marking them as equal. So these two sides are same and these two angles also will be same. So angle E and angle F. Angle E and angle F should be same and these two sides are same. In right angle triangle, if one of the angles of triangle is 90 degrees, I call that as a right angle triangle. So this is 90 degrees angle. So I'll just name that as a GHI. And for right angle triangle, we have we have this 90 degrees angle. The side which is opposite to 90 degrees angle, we call that as a hypotenuse. So in this case, the side GI is hypotenuse. And as we know, as a Pythagoras theorem, the sum of squares of the sides is equal to square of hypotenuse. So in this case, if I name this as a G, H, and I, these are sides. So it should be I square should be equal to G square plus H square. This is the Pythagoras theorem. Now we have seen different types of triangle. Now we'll just move to some formulae of triangle and some properties of equilateral triangle. See the area of triangle, how do we calculate it? So area of triangle, so if I have to compute, the formula is 1 by 2 into base into height. So if I consider a similar triangle, triangle A, B, C. So what do you mean by base and height? So base can be any side of the triangle and height is the altitude which is drawn to that side. So in this case, if I consider side BC and the length of side is B, if I draw altitude from A to side BC, I'll call this as H. So this is my H and this is my side B. So in this case, what should be the area of triangle? It should be 1 by 2 into base into height. So by considering this B and H, we can compute the area of triangle. There is another way to compute area of triangles if we know the length of all three sides. So in this case, length of side BC is B. So if I know length of side AC as C and length of my side AB as B. So if I know all these three sides, I can compute the area of triangle with another formula, which is root S minus A, S minus B, S minus C. So in this case, what is S? S is 1 by 2 into perimeter of this triangle. So if you know all the three sides and the length of three sides, we can compute S first, perimeter of the triangle by 2, and we can compute area of triangle with this formula. So as we have seen the area of triangle, different formula, we'll move to some of the properties which are specific to equilateral triangle. Okay, so now we'll see two formulae which are specific to equilateral triangle. So if I consider equilateral triangle, triangle ABC, same triangle, each angle is 60 degree here. So as I mentioned, like the altitude of this triangle is also median. So it will divide the side BC into equal parts, and this is perpendicular to side BC. So if I have to compute AD, length of AD, I can compute the length of AD with very simple formula. AD should be root 3 by 2 into side. So side here is BC. If I have to compute AD, I can just take, if I know length of BC, I can compute it BC AD by multiplying by root 3 by 2. There is one more formula to compute area of triangle, equilateral triangle. is root 3 by 4 into side square. So as we know, every side is equal, and if we just know length of any side, we can compute the area of this triangle by multiplying the side square by root 3 by 4. So these two are very important formula which is used in many numericals. So maybe we'll move to numericals in the next part. So as of now, we just what we have seen, so basic concept we have seen, then different types of triangle and some formula of area computation and some specific properties of equilateral triangle.